Good morning students. Welcome back. Yesterday in the live class and in the video that was provided to you in your ERP, we had discussed about similar triangles, similar figures, not similar triangles, rather similar figures, square, rectangle, rhombus, right? And now we had also discussed about your basic proportionality theorem. Yes, we had proved basic proportionality theorem and we had also discussed about certain questions from exercise 6.2 on page 128. Now today we are going to discuss about question number 5, 6, 7, 8, 9 and 10 on page 129. See, in ninth class when we discussed geometry, that time also I had told you that observation is important. Yesterday also when we discussed about BPT and all, observation, last two questions that we discussed, question number 3rd and 4th of exercise 6.2, right? I told you that observation is very important. And some students feel that this geometry is very tough. Geometry is not tough. Geometry is one of the easiest topics only because everything is visible to us. We can see everything. That is why geometry becomes very, very easy. Okay. Everywhere you have to observe the things which are visible to you and write down whatever you see. Don't worry about what they are asking. Just write down whatever is visible to you. Okay. So here, today we are starting with page 129, question number 5 and question number 6. You can see similar figures over there. So we will do both of the questions together. Question number 5. In the given figure 6.20, DE is parallel to OQ and DE is parallel to OR. Now see, we were discussing about BPT yesterday. BPT was all about a line parallel to one side of a triangle. That's it. So whenever you see a triangle and in a triangle you see a line which is parallel, so the first thing that should strike us is what? BPT. The very first thing that should strike is what? BPT. So here also is saying in the figure side DE is parallel to OQ and DF is parallel to OR. So let us draw the figure and write down whatever is given to us. Question number 5. This is the figure given to you. Right? Triangle ABC, sorry, not triangle ABC, PQR, and this DE is parallel to QR. DE is parallel to OQ. This. Can you see that? This is O and this is D and this is E. Sorry. This is D and this is E. This is E and this is D. See the figure. This DE is parallel to OQ. We have drawn the figure. When we draw the figure, it is visible to us. In the figure given to you, this arrow sign is missing. So we have marked it. And as soon as we see a triangle with a parallel line, the first thing that strikes is what? BPT. So can we see the rest of the two sides of this triangle are going to be divided in the same ratio? Yesterday we had discussed. Write down what is given. Given DE parallel to OQ and DF parallel to OR in the given figure. In the given figure. What you have to prove? Write down, it is given to us. He tells us to prove that EF is parallel to QR. Prove that EF is parallel to QR. Now, let us complete the figure construction. Not required. We will see what is to be constructed in future if it requires proof. Can you see a triangle? In which triangle? In triangle POQ. I have not drawn the complete figure so that you can easily identify. In triangle POQ. Yes. DE is parallel to OQ. DE is parallel to OQ. So therefore, the rest of the sides, which are the other two sides, PQ and PO, will they be divided in the same ratio? Yesterday, turn down to your page 124. Yesterday we had proved BPT. It says in a triangle, if a line is drawn parallel to one side of a triangle, can we see a line DE parallel to one side of this triangle POQ? Isn't it? So therefore, the other two sides are divided in same ratio. Therefore, PE upon EQ is equals to PD upon DO. Equation number first, I will name it, and reason for that, by BPT. We don't need to write the complete statement, we can write BPT. Name of the theorem. Right. Now, next he says DF is parallel to OR. This is DF and this is OR. DF is parallel to OR. Can you see again two arrows are there? Again which triangle? POR. In triangle POR, DF is parallel to OR. So therefore, DF, the other two sides, which are the other two sides? PO and PR. So can I say that PF upon FR equals to PD upon TO. Equation number second, reason same, by BPT. Yes. Now this are the two quantities given to us. These are the two things given to us. According to those two things, we have marked it. Now what else? Now he says, prove that EF is parallel to QR. Where is this EF? This is EF. Can you see that? And this is QR. EF is parallel to QR. So let me check what do I have from equation first and second. From equation first and second, I can see that right hand side is equal. PD upon DO is equals to PD upon DO. Right hand sides are equal. So from equation first and second, right hand side is equal. So left hand side is also equal. I can say that PE upon EQ is equals to PF upon FR. This is what I can say. Now let me check where are these. PE, EQ, PF and FR. These are the parts of the sides PQ and PR. The sides PQ and PR are divided in the same ratio. So turn down to page 126. Converse of BPT. Theorem number 6.2 we have proved. We had applied yesterday as well. Right? What does he say? It says if two sides of a triangle are divided in the same ratio, then the line is parallel to the third side. EF is parallel to the third side. So in which triangle now? In triangle PQR. So therefore, in triangle PQR, the sides PQ and PR are divided in the same ratio. Sir, where is it divided? Can you see this equation number third? I name it equation number third. In equation third. So therefore, EF is parallel to QR. Reason by converse of BPT. Yes, by converse of BPT. And what is the converse of BPT? It says that if a line divides two sides of a triangle in the same ratio, then the line is parallel to the third side. Isn't it? Same application, students. There is nothing new. Question number 6, if you observe, it is the same. In the given figure, A, B and C are the points on the sides OP, OQ and OR respectively, such that AB is parallel to PQ, AC is parallel to PR. Let us draw the figure. You will observe that same application is there. There is nothing new. Question number 6. Again there is a triangle PQR. And I have always read the question and drawn the figure for you. And you also do the same. You will be able to identify. If we just look at the figure and we draw it, no, it becomes slightly difficult. It says in the given figure, A, B and C are the points on the sides OP, OQ and OR. So that is OP, so this is OP, this is OQ and this is OR. Right? A and B are the points on the sides OP, OQ and OR. A, B and C. He did not say midpoint or anything as such. Now he says AB is parallel to PQ. Can you see this AB? Is it parallel to PQ? So can we see a triangle with a parallel line? Yes. Which is the triangle? POQ. AB is parallel to which side? PQ. So will the rest of the two sides be divided in the same ratio? Can we write it? Write it down. Don't worry about what is asked. Given AB is parallel to PQ and AC is parallel to PR in the given figure. In the given figure. What we have to prove? We have to prove that BC is parallel to QR. Construction not required. Only observation. See, I have not completed the figure. Let me write down what is visible to us. Proof. In triangle POQ, AB is parallel to PQ given to us. POQ. AB is parallel to PQ. So the rest of the two sides, which are the other two sides? OP and OQ. Will they be divided in the same ratio? Reason BPT. In triangle POQ, OA upon AP equals to OB upon BC. OA upon AP equals to OB upon BQ. Equation number first. Reason by BPT. I am repeating the statements again and again for you. What is BPT? If a line is drawn, AB parallel to one side of a triangle PQ, then the other two sides OP and OQ are divided in the same ratio. Similarly, AC is parallel to PR. This AC is parallel to PR. In triangle POR, AC is parallel to PR. AC is parallel to PR. The rest of the two sides are divided in the same ratio, OP and OR. So therefore, OA upon AP equals to OC upon CR. Equation number second. Reason same by BPT. So again, can we see from equation first and second, is the left hand side equal? So right hand side is also equal. From equation first and second, OB upon BQ equals to OC upon CR. What did we get? What did we get? Observe. OB upon BQ equals to OC upon CR. So can we see this line BC? In which triangle? QOR. In this triangle, the two sides are divided in same ratio, OB upon BQ, OC upon CR. These two sides are divided in the same ratio. Then the line will be parallel to which side? The third side. Same reason. So therefore, in triangle QOR, the sides OQ and OR are divided in the same ratio. Where can we see that? Equation number third. Check. Yes. So therefore, the line BC is parallel to QR. Reason by converse of BPT. Can you see both the questions? It is same. We have to observe the triangle. We have to find the triangle with a parallel line, and we just have to apply BPT, nothing new, only observation. Clear? Question number 7 and 8, you can see theorem 6.1, 6.2. And there is a bracket written last line. Recall that you have proved it in class 9. That is question theorem of class 9. Now, 9th class, I had previously also stated, 9th class is very important, was very important for you all. Page number 148 of your textbook of class 9, not this class 10, of class 9, there was midpoint theorem. Remember, both these questions are based on midpoint theorem. We will discuss both these questions together. We will draw the figure. Figure is not given to you. We will have to draw the figure and then we will see how they are similar to each other. Question number 7. Using theorem 6.1, prove that the line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. Question number 7. What does he say? In a triangle, the line drawn through the midpoint of one side, say this is triangle A, B, C, and this B is the midpoint of AB, and this DE is parallel to BC. This is given. So what is given to us? We are given triangle ABC in which DE is parallel to BC and D is the midpoint. D is the midpoint of BC. What we have to prove? We have to prove that it bisects the third side. We need to prove that AE is equals to BC. E is the midpoint of AC. That is, we need to prove that AE is equals to EC. Let us talk about question number 8. What does he say? In question number 8, he says, using theorem 6.2, prove that the line joining the midpoints of two sides. Here it was line joining the midpoint of one side. Here he says line joining the midpoint of two sides. So this is one triangle. A, B, C, D and E both are midpoints. AD is equals to DB and AE equals to EC. Oh, sorry. Right? What is given? The line joining the midpoint D and E. D and E are the midpoints of the sides AB and AC respectively of triangle ABC. What we have to prove? We have to prove that DE is parallel to BC. Can you see both these questions? Here in this question, DE was parallel to BC given to us. Here we have to prove. Here it was given that D is the midpoint. Here also D and E both are midpoint. Here we have to prove that E is the midpoint. Here it is given that E is the midpoint. Both the questions. And he says, see, it is saying over there, recall that you have proved it in class 9th. If you recall this, we have proved it in class 9th. Midpoint theorem. Alright, and I had stated that in the class as well, that when you do this midpoint theorem, it will be applied in class 10th as well. Alright, so let us see. But here he says, use it by what property? Theorem 6.1. In exam, it is not going to be written. Use theorem 6.1. You can solve it by any method. Why not 6.1? Because 6.1 is used for this textbook only. Some different schools, some different places, different textbooks are used. So it's not necessary that this is the 6th chapter. Alright? So don't assume, don't write 6.1, write down the name. Here he can say, use BPT to solve this. Alright? So let us come back over here. Construction. Not required, everything is constructed. So what can we observe? My question is always observation in geometry. What do we observe? We observe a line DE is parallel to BC. Can we observe that? Definitely, sir, this DE is parallel to BC, visible to us. So, can we apply apply BPT? BPT, for application of BPT, it is what? A line must be parallel to one side of a triangle. Apply. In triangle ABC, DE is parallel to BC. So therefore, the rest of the two sides, AD upon DB, is it equals to AE upon EC? Equation number first. By what theorem? BPT. What is BPT? If a line is parallel to one side of a triangle, the other two sides are divided in the same ratio. But one more thing is given. What? AD is equals to DB. But AD is equals to DB. Reason given to us. Given. What is given? That D is the midpoint of BC. If it is the midpoint, AD is equals to DB. Now check AD and DB. Are both of them equal? Now AD upon DB is equals to AE upon EC. Can I replace DB by AD or AD by DB because both of them are equal? So I can write it as AD upon AD is equals to AE upon EC. AD and AD cancel one by one. So 1 is equals to AE upon EC. EC is cross multiplied to 1. So EC is equals to AE. Is that what we need to prove? We need to prove that AE is equals to AC. That is, this E is the midpoint of. Any confusion? Only application of BPT. Can we apply BPT over here in this question? No. Why not? This line is not parallel. We have to prove. Can we apply? Did we apply BPT over here? Yes. Why? Because DE was parallel to BC. That was given to us in the question. Here we have to prove. We cannot apply BPT over here. Then what can we apply? Observe, observe, observe. What can we see? Proof. Because D and E are the midpoints of AB and AC respectively of triangle ABC. Therefore, can I say that AD is equals to DB? Definitely, sir. Can I say that AE is equals to EC? Definitely, sir. Right? Both of them are equal midpoints. So therefore, AD upon DB will be how much? 1 by 1. Because both of them are equal, or you can do one more step. What? In place of DB, can I write it as AD upon AD? Because DB is equal to what? AD. AD and AD cancel. What do I get? 1 by 1. Equation number first. Similarly, AE upon EC. Can I write it as AE upon AE? Sir, why? Because EC is equals to what? AE. AE cancel. What do I get? 1 by 1. Are the two sides equal? So from equation first and second, AD upon DB is equals to AE upon EC. These two sides are divided in the same ratio. If these two sides are divided in the same ratio, then the line is parallel to the third side by converse of BPT. In the previous two questions also we have done the same. Isn't it? By converse of BPT. So therefore, in triangle ABC, the sides AB and AC are divided in the same ratio, where in equation number 3 you can see. In equation number 3. So therefore, DE is parallel to BC. By what theorem? By converse of BPP. See students, this exercise, this chapter is very easy if we have it in our heads what is to be applied. As soon as we see a line parallel to one side, BPT should be applicable. right? As soon as we see if two sides are divided in same ratio, then we can say that converse of BPT is applicable. So that is how you will identify what is to be applied. It's not new. Okay, say take a look at question number 9 and 10. Both are same, figures are not provided to you. But instead of triangles now, he is talking about quadrilaterals and a trapezium. Quadrilaterals and a trapezium. Read it carefully. He says, ABCD is a trapezium in which AB is parallel to DC and its diagonals intersect each other at O. Diagonals intersect each other at O. Whereas in question number 10 he says, that the diagonals of a quadrilateral ABCD. So can you see the difference? One is saying a trapezium, the other one is saying a quadrilateral. Isn't it? One is a trapezium, the other one is a quadrilateral. So let us check, let us draw the figure, question number 9. ABCD is a trapezium. This is a trapezium in which AB is parallel to CD. A, B, C, D. AB and CD are parallel to each other. What is given? Trapezium ABCD in which AB is parallel to CD and diagonals intersect at O. Intersect at O. What we have to prove? We have to prove that AO upon BO is equals to CO upon DO. Right? This is the diagonal 1. This is the diagonal 2, and both of them are intersecting at. Whereas in question number 10, see what does he say? He says, in the diagonals of a quadrilateral, ABCD intersect each other at O. This is a quadrilateral. A, B, C, D. The diagonals intersect at O. He did not say it is a trapezium, so I did not mark it. The diagonals intersect at O. What is given? Quadrilateral A, B, C, D in which OA upon OB equals to AO upon BO. It is the same, no matter. AO upon BO is equals to CO upon DO. And what you have to prove? We have to prove that ABCD is a trapezium. Check now. Both the questions are there in front of you. This question is again going to be there in the next exercise. Alright, check. Here is saying trapezium ABCD, so two sides are parallel. We have to prove AO upon BO. Then is given AO upon BO equals to CO upon DO, and we have to prove that it is a trapezium. That means, in other words, we need to prove that this AB is parallel to CD. Are they converse of each other? Now the question arises, sir, where do we apply BPT? BPT is applicable in a triangle. There is no triangle with a parallel line, isn't it? So where do we apply it? So here we will have to do a construction. What construction? Just observe. We will dividing this trapezium into certain parts by drawing a line parallel to AB and CD. This is MN parallel to AB and parallel to CD. Since it is parallel to AB, it is automatically going to be parallel to CD. Why? Again, class 9th, page 101, theorem number 6.6. Lines parallel to the same line are parallel to each other. Those you must have studied in class 9th. Your teacher must have told you to fold that page 100. It is a very, very important page number 100 and page 101. Important theorems are there. Construction. What is the construction? MN parallel to AB and CD. Passing through O, I write. Passing through O. Now can you identify a triangle with a parallel line? Four triangles you can identify. Take a look. ADB, another triangle ACB, another triangle DBC, another triangle CAD. Four triangles are visible with a parallel line. So we'll observe. Take a look at triangle ADB. Can you see this? This triangle. Is MO parallel to AB? In triangle ADB, MO is parallel to AB. Reason, because MN is parallel to AB by construction. If MN is parallel, a part of MN is automatically parallel. So can you see which of the rest of the two sides of this triangle? These are the two sides, AD and DB. Will the other two sides be divided in the same ratio? Definitely. Which are the other two sides? AD and DB. In triangle ADB, DM upon MA equals to DO upon BO. Yes or no? DM upon MA equals to DO upon BO. Equation number first. By what theorem? By BPP. Alright. Another triangle that we have to see, in which same figure come DM and MA. So DM and MA is this. Which is the other triangle? ADC. Is this MO also parallel to CD? Yes. In triangle ADC, MO is also parallel to CD. Reason same, because MN is also parallel to CD. So therefore, DM upon MA is equals to CO upon AO. Is equals to CO upon AO. Equation number second. Reason by BPP. Is the right and left hand side equal? So from first and second, from equation first and second, left hand side equal, so right hand side is also equal. BO upon BO is equals to CO upon AO. Yes. Simple transformation now. Interchange the places of DO and AO. AO comes over here, DO comes down. So AO upon BO is equals to CO upon DO. Hence, only application of BPT. Yes, only thing was to observe which triangle should be taken. Same here. Here we have done a construction. MN was parallel to AB, so automatically this MN was also parallel to CD. But here AB and CD are not parallel. Then what? So then it will be parallel to any one of them. This is MN passing through O, but now this MN can be parallel to either AB or to CD. So I am making it parallel to say AB. MN parallel to AB passing through O. So proof again, identify the triangle with a parallel line. Check again, same triangle ADB. In triangle ADB, MO is parallel to AB. So therefore, DM upon MA equals to DO upon BO. Equation number first by BPP. DM upon MA equals to DO upon BO. Right? But now we need to prove it parallel. AB parallel to CD. So this MO is not parallel to CD as it was over here. That is not possible. Then what? So observe what is given to us. This is given. And AO upon BO is equals to CO upon BO. This is given to us. Can we interchange the places? So what do I get? DO upon BO is equals to CO upon AO. Equation number second. Check now. Is one side equal? So will the other side be also equal? So from equation first and second, one side is equal, so other side is also equal. dm upon ma equals to co upon ao. Equation number 3. Now where is this? dm upon ma equals to ao upon co. Sorry, co upon ao. dm upon ma equals to co upon ao. Which two sides of the triangle are in the same ratio? Triangle ADC. If two sides of a triangle in the same ratio, then the line is parallel to the third side by which theorem? Converse of BPT, isn't it? So here we can say, so therefore in triangle ADC, two sides, which are the two sides? AD and AC are divided in same ratio. Where? In equation number 3rd. Can you see that equation number 3rd? dm upon ma is equals to co upon au. Therefore, the line is parallel to the third side. So therefore, mo is parallel to cd by converse of BPT. But MO was parallel to AB. Yes or no? By construction, MN was parallel to AB, so MO was parallel to AB. But MO is also parallel to CD. MO is also parallel to CD. Proved above. So will AB be parallel to CD? Because so therefore MO is parallel to AB is parallel to CD. Write down the reason. Lines parallel to the same line are parallel to each other. So therefore AB is parallel to CD. So ABCD is a trapezium, hence true. Correct, students? So this is what we have done in your BPT. It is application of BPT, nothing else. I hope you were able to understand all these 6 questions. If you have any doubts, you can always ask.